Today the technique I'm going to use, since this is a perfectly round cylinder and it doesn't have any pouring lips or anything on it, I can make a very tight seal with folded up paper towels, and I'm not going to hold the suspension against it long enough to absorb a significant amount of water. I'm going to suspend the soil particles, set the cylinder back down, take a 40-second hydrometer reading, and I'm going to repeat this procedure 3 times. The reason I do it 3 times is because when you're taking that first reading, that 40-second reading, there's always a little bit of room for error, and I'm going to basically take an average of those 3 40-second readings to determine what amount of soil has settled in that 40-second time period. So I'm going to begin the 40-second time period right now. What I need to do is to get that hydrometer in there without dropping it and get it to slow down or equilibrate. Right now it says we have approximately 30 grams of solids left in suspension. We're approximating about 35 seconds right now. And at 40 seconds we'll take the reading, and that reading will be 27. So you should write down on your lab handout 27 grams per liter, which is what the hydrometer is measuring. That's basically saying that 27 of the original 50 grams are remaining in suspension at this point in time. And I'm going to resuspend this. I'm going to do this 2 more times and take the readings again so that we get an average of those 3 readings. Here again, we'll have a little bit of soil that may hold up here, but that's not a significant amount in comparison to the total weight of the soil that we had to start with. You notice that as the soil settles out with time, the hydrometer sinks deeper into the soil because obviously there's less density there as the soil settles out. We've had approximately 30 seconds again right now. And our next reading is also 27. So that didn't change between reading number 1 and reading number 2. So we would write 27 down again underneath our second 40-second reading for this. We'll do it one more time. You notice as we've done this, we've dropped the volume very, very slightly in here below the 1130 mil mark due to some absorption of water by this paper towel, but that's not a significant amount. Okay, that 40-second reading is going to be 26. So we'll record a 27, a 27, and a 26 on our data sheet. After we've taken the 2-hour reading, we can now start looking at our 2-hour time limit. So we're going to basically leave this suspension undisturbed for a period of 2 hours, at which time we'll come back and take an additional reading of both temperature and with the hydrometer. During this 2-hour time period, all of the silt-sized particles will have settled out of this soil. So our 3 readings of 27 each, twice, and then 26, we'll take an average of that. That will be our readings that will basically be telling us what amount of total silt and clay is still in suspension at the end of that 40-second time period. We will then take the reading at 2 hours. The 2 hours, the only thing left in suspension at the end of 2 hours will be the clay-sized particles. If we know the percentage of silt and clay together, plus the percentage of clay, we can determine silt by difference of those two numbers. And those two numbers added together, silt plus clay subtracted from 100% of the total soil volume or total soil textural class, will give us the percentage of sand that was in this sample. So with that information, you can, we'll wait for the 2-hour reading, and then after that point in time, I'll go through and brief you on how to take this data over and utilize the formula to calculate your percentages of sand, silt, and clay, and take that to the textural triangle to determine textural class name.